In this video, we will talk about testing. In particular, I want to make sure that you're aware of some important issues with assessment tests. I will be mixing different approaches and simplify things a lot, hoping to just get across the main concepts that you should be aware of when you are involved with assessment tests. So in a typical situation, possibly related to suspected reading difficulties, you're going to have a wide range of tests that you can use, such as tests of word and pseudo-word reading accuracy, word and passage reading fluency, phonological awareness, vocabulary, syntax, and what have you. A whole bunch of different tests. So how do tests actually work? Let us take a very simple example of a receptive vocabulary test. This kind of tests, where there are 4 pictures, and the tester says, for example here, horse, and the child has to point at this one. So the general structure of this kind of test is that the tester speaks a word, the person being tested chooses a picture, which is then recorded and graded with 1 point or something like that. And that's done for different pictures again and again. And in the end, you add up all these points and you get a vocabulary score. And that is meant to represent the breadth of your receptive vocabulary. So the way that people may think about this is that we have some sort of vocabularometer, that's not really a word, like a ruler, and that the number of correct responses just directly indicates your vocabulary. This is how this is treated. However, the situation behind this, both in constructing the test and in assessing and interpreting the test, is much more complicated. First of all, there is a distinction between that which you can see and that which you cannot. What we're interested in a situation like this is the person's vocabulary, which is in their mind. We cannot see this. This is what we want to know. How many words do they know? Lots of words or a few words compared to their peers. We can't see this, so what we do is we invent these kinds of interactions with vocabulary tests, and so we get the responses and then we count them. And then we add up the number of correct responses. So this is what we actually have, and this is what we really want. This is called a latent construct. Latent because you can't see it, and construct because it's a theoretical construct. We assume that in people's minds there are sets of words that are represented. There is good reason to assume that. It sounds very reasonable, but it's still a construct because nobody can open anybody's head and find words stored in there. This, on the other hand, is an observable index. It's observable because we observe actual responses. We can videotape them if we want. They're truly visible. And it's an index because we use it to indicate this one, which is what we would like to know. Let's think about some fruit instead. So if you have 1 apple and 1 apple, that's 2 apples. Okay. If you have 1 apple and 1 lemon, that's not something in particular. Okay, if you have 1 correct response and another correct response, is it more like 2 apples, or is it more like 1 apple and 1 lemon? If the questions aren't the same, then this is not very straightforward to answer. And the questions are never the same. So in a vocabulary test, we ask different words. In other kinds of tests, there's always a set of different questions. So it's not clear that we should be adding those, but we do that. And the reason that we do that is because the number is used to indicate something else that we have conceived of, and that's the idea of probabilistic responding. This idea is that, well, when you have a high vocabulary, you are more likely to answer correctly to word questions, and then we repeatedly sample this ability of yours by using lots of different words, and we use the observation of whether you answered correctly or not in conjunction with our knowledge of the probability of answering these correctly in order to conclude something about your vocabulary. This means that when the test is constructed, someone actually has been concerned with the probability of correct responses. So that if we have a bunch of different items, or different words in this case, with associated picture sets, then these probabilities of correct response for the different items can, taken together, indicate someone's vocabulary level. What are these probabilities like? Here is the main idea about what a good vocabulary item or any test item should look like. What does this mean? This is a graph of the probability of correct response as a function of this latent construct of vocabulary. So a good item in such a test is an item that has very low probability of correct response for those with low vocabulary, very high probability of correct response for those with high vocabulary, and a transition area in the middle that just joins them without going back and forth. This is what we're striving for. This means that people with low vocabulary should not be answering the question correctly, indicating they don't know the word, whereas people with high vocabulary should be answering the question correctly, indicating they know the word. If the probability curve looked like this, that would be a problem. This would not be usable in a test. What does this show us? This shows us a hypothetical item for which people with low vocabulary and people with high vocabulary are highly likely to answer correctly, but people with intermediate vocabulary are not likely to answer correctly. And we can also imagine the inverse. This is a hypothetical item which people with low vocabulary don't know, don't answer correctly. People with high vocabulary also don't answer correctly because maybe they have so good knowledge that they realize this is not exactly the right answer, but people with intermediate levels of vocabulary answer correctly. So these kinds of items cannot be included in the test. But all items have to be like that. We're not done yet. The person who made the test didn't only have one item and didn't have all equal items. As you know, in tests, there are items of different difficulty. What does this mean? And why is it there? Well, in this imaginary item here, we have people with very poor vocabulary and people with about average vocabulary, both having low probability of correctly answering. So asking this word, this question, cannot distinguish someone with poor vocabulary from someone with average vocabulary because they both are likely to get it wrong. Also, both people with good vocabulary and with exceptional vocabulary are very likely to answer this one correctly. So this item cannot distinguish someone with good from someone with exceptional vocabulary because they're both likely to get it right. So this item, this imaginary item, can only distinguish between people with average vocabulary from people with good vocabulary. So each item can only distinguish within a limited range. And so we need lots of items. So the yellow item here is answered correctly by everyone. So from here upwards on the vocabulary scale, except here, so except those with very poor vocabulary. So this is an easy word that is known by almost everyone except those with very poor vocabulary. The item depicted in orange, in contrast, is answered incorrectly by everyone except those with very high vocabulary. So this would be a very difficult word that only few people know. And having lots of items dispersed across the range of difficulty allows the test to be able to distinguish different levels of the skill across the whole range. And that's how items are designed. So by choosing our items appropriately and adjusting the probability of correct response for each one, then we can use the actual responses of any individual person to estimate where this one might be for this person. One very important property of a good test that might make us believe it is that it should be stable. Stable in the sense that the answer we get, the score we get from the test, does not depend on when the test is administered. So one easy way to check that is to administer the same test twice. And a stable test will give the same score twice. Actually, it will never give the exact same score, but there should be a very close connection, a very high correlation between the first administration and the second. And here are data for a very different vocabulary test administered once and then a second time. So each point here, each yellow point, displays the score obtained in the first administration versus the score obtained in the second one. And this dashed line here is where all points would be if everyone got the exact same score twice. As you see, there aren't any points on this line, but there's only one point below the line and all the other points are above the line, which demonstrates that everybody got a better score the second time, which is very common and expected because of the effect of retesting. So the second time, people are familiar with the test. So familiarity affects the score, and everybody, almost everybody, gets a higher score. This is a histogram of the differences between the first and second measure. This is the one person who happened to get a lower score the second time. And this is a person who got 12 points higher the second time, which means something is wrong here. Maybe this person was distracted or sick the first time. Overall, we get about 2.5 points difference between the first and second administration of the same test, which is acceptable for a test of this kind when the two administrations are not very distant in time. So a bit more generally, the notion of reliability of the test, which makes us trust the score we get from the test, includes some components, some different components. One component is called internal consistency, and that has to do with the correlation between items. This means that a test that is consistent has items that are chosen so that someone who is likely to answer one correctly is also likely to answer other items correctly. So if that happens, it means that all items are assessing the same latent construct. If performance on one item is unrelated to performance on other items, this means that the items do not all assess the same latent construct and do not belong in the same test. And then there is also stability in terms of repeatability, which is checked by re-administration, as in the example I just showed you. If these conditions are satisfied, then we can trust that we're measuring something. So if the scores are consistent and stable, then it looks like we're measuring something. Now, what we're measuring is a different question we'll get to soon. Before that, we have to think of a different property of tests, namely that the test should be sensitive to development. That is, that test scores should grow as children grow because their skills are also expected to grow. So here are the scores for boys and girls in a vocabulary test. And this turns out to be a not very good test in the sense that the expected scores for boys and girls at the same age are different, meaning that the chosen words or the chosen pictures are easier for boys than for girls for some reason. And we can see, for example, that a raw score of 20 is the average expected for boys of 4 years, 3 months old, but for girls at 4 years, 8 months. and an average score of 30 is expected for boys of 6 years 4 months, but girls at 7 years. Other than that, we see that scores increase with increasing age, which is a necessary feature of any adequate test. However, this is very misleading if you use it backwards. What does it mean to use it backwards? It means to use the score from the test in order to derive an age. And you may have seen things like reading age or spelling age or things like that. And that's going from a score to the age at which this score is expected on average. The reason this is misleading is twofold. One problem is that differences in raw scores change very differently with age at different points in the range. For example, here, a 3-point difference from 19 to 22 correct responses is seen as average scores for boys between 4 years 1 month and 4 years 7 months. So 3 points in the test correspond to 6 months of development at this age. At the other end of the scale, going from 33 to 36, which again is 3 points, corresponds with the difference from 7 years 1 month to 8 years. So 3 points difference here is associated with the whole year of development. So 3 points is not very informative in itself. The second reason that this going backwards is a problem, perhaps the most important one, is the variability. So these are the actual data points for all the children participating in the standardization of this test. And this is the curve of the average expressing the fact that the growth is not linear. So it's not going up as a straight line, but there is a faster growth in younger ages, and it's kind of tapering off as children grow older and reach better and better performance. This is commonly expected for two reasons. One is that children in the beginning don't know anything, so that their development is rapid, whereas it slows down later on. And the other is that tests don't have an unlimited number of items, so children eventually reach the point at which they answer all or most of the items, resulting in a ceiling effect, depressing the variability here. But the other issue is that everything within this zone between the two yellow lines is normal average performance. So the red line is the average, goes through the average at each age. And the yellow lines indicate the zone of normal performance around this exact average. And as you see, this is a wide band. We know not all children are equal, but there is a range of performance that is normal, and they can be a bit higher than average, a bit lower than average, but still normal. Now, if we consider the average performance for a child at age 70 months, so we can see that the actual range of performance is from really low to really high. And let's say this is the average performance range. So children can have performance anywhere here when they're 70 months old, and we call that average performance. So a child that has average performance well within the band at 70 months has performance here that is equal to the average for children of 58 months. So if someone was reporting this child's score as relative to their own age, they would say this is within average range. It's not even low. Someone reporting the developmental age of this child, they would say this child is 1 year behind, which sounds really scary. Sounds like you should be doing something. But you shouldn't. This child is doing just fine. They're very well within the zone of normal performance. And the problem here is that the slope of growth, when taken into account the width of this zone, is not steep enough to justify going backwards and making this interpretable. So that's why you should avoid reporting and interpreting developmental ages of any sort. Now let us go back to our vocabulary test as an example of what goes on in a test. Let me clarify that I use this diagram that says vocabulary here, but I am making points that are much more general and apply to any kind of assessment test. This is just for illustration, so that you keep in mind the distinction between a latent construct and an observable index. So what else affects whether you answer correctly or incorrectly to a test like the one we saw? Of course, whether or not you actually have the word in your mental lexicon really should affect whether or not you answer correctly. But that's not the only thing that affects performance in these tests. There's a whole bunch of other things that affect performance, and that depends on the design of the test. And these are, for one part, a number of general things like intelligence, memory, experience, for example, experience with tests, general knowledge of other kinds of things, situations, whether you get stressed in testing situations or not, and a whole bunch of general things will also affect whether or not you answer correctly a question about vocabulary. So this thing that you obtain doesn't only depend on this thing that you want. Let's see an example of a poorly designed test that we applied, trying to figure out whether some patients with aphasia had differential difficulty inflecting verbs for agreement, tense, and aspect. So this is a test we made, wanting to see if people could express the proper verbal inflections. So the examiner would say, I write notes. He and the patient would have to say, writes notes. So they would have to produce the third person to agree with the cue. Or the examiner would say, Jenny writes letters. Tomorrow, Jenny, and the patient would have to say, will write letters. So using the plural. And here they would have to use the finite or a non-finite aspect of the verb. And we found that patients had more difficulty with the aspect of the verb than with tense, and more difficulty with tense than with agreement. Do you see anything wrong with this test? How about if I show you the improved test? The problem with this test is that it is much easier to remember the cue and the sentence for this case than for this case, and much worse for this case. So then we made another test of the exact same sort, but equating the sentence structure and length for the three conditions. So here this says, this morning again, I write notes for my students. This morning again, he, and the patient has to say writes notes. So it's the same test, but with equally long and equally complex sentences. And not surprisingly, the difference disappeared, which means that the patients did not have differential difficulty with these different verbal inflections, but had differential difficulty remembering things because some things were more complex and longer than others. So that was poor design of the test. Here's another poorly designed test we've tried. This was meant to be used as a vocabulary test for second language learners of Greek. So for immigrants to Greece who were learning Greek, they were given this page with images, and they would have to fill out the word for the image. As it turned out, when analyzing the pilot data for this, we discovered that it was not highly related with the rest of the language tests we had. Can you imagine what it was related with? It was with their spelling ability. So what we had intended as a vocabulary test was not a good vocabulary test because it depended on other things in addition to their vocabulary, indeed more strongly on other things, because these were not very difficult elements from a vocabulary point of view. So we didn't end up using this test. In some cases, you get a score that depends on other things because of poor design or things you didn't think of early enough. In other cases, this is an inherent problem associated with your construct. Imagine you want to make a test of comprehension. Now, comprehension is not really one thing because in order to understand, you have to be doing a bunch of things like remembering information, making inferences, integrating with context, metacognitively monitoring whether you are understanding or not. And it's not necessary that all of these sub-skills will be equally strong. So a correct response on a comprehension question may depend to differing levels on these different sub-constructs. So when you're trying to measure comprehension, you're faced with an impossible task. You can either try to assess all of these, in which case you will get a test that is not very reliable because these aren't completely perfectly correlated. Or you can get a test which is very reliable by focusing on only one of them and then ignoring the others, thereby not getting a test of comprehension, but of something much narrower. The opposite problem is also possible. So imagine that theory tells you there are two different kinds of abilities, and each kind of ability leads to correctly or incorrectly answering different kinds of questions or providing different kinds of information. Here is an example from another test we've made, and this is a commonly used test of expressive language development for young children. The examiner shows a picture like this one and asks, what did the cat just do in this case? And then you write down what the child says, and then you score points for saying the appropriate words. So a relevant verb, the number 2, the word mouse, and you score separately for proper grammar. So using the correct verb, that it's in the past, correct subject-verb agreement in the sentence, use of the plural, these are also scored, and they're scored separately. So the child gets an information content and a grammar score. So when we analyze the result from the standardization and try to fit a two-factor model with content and grammar, we obtained a result that is mathematically impossible. This number cannot be greater than 1. This makes no sense. And the reason for this making no sense is that we had too many factors in the model. So when we tried this again, but with considering only a single language factor, then the model fit just fine and the test worked just fine. So the data actually were not consistent with the theoretical assumption that vocabulary and grammar develop separately and can be distinguished by testing. Instead, we should have used a single factor, which is what we ended up doing. And this result has been replicated by many other groups also. What else should we be aware of when we are administering and interpreting a test? Let us go back to our simple vocabulary example. What affects whether or not you give a correct response? Well, obviously, your vocabulary affects it. Hopefully, this is dominant, but you can't know that. There's a bunch of general factors that are also affecting it to some extent, and your memory and your stress level at the time of testing and your experience and so on. But there's something else as well. The fact that this is a test of picture selection means that how well you can see, well, obviously you have to be able to see, and how well you can recognize and identify and select pictures will also affect the probability of replying correctly. And indeed, if you have difficulty with categorizing pictures, this might be the cause of an incorrect response, or the cause of increased stress levels, or the cause of mental effort that will diminish your ability to dip into your vocabulary and think about it correctly. So this is different from these because these lower things are general skills and abilities of the person tested, whereas these are task-related demands. These are things that relate directly to how the interaction in the test is designed, and they also affect performance. This is a problem that can be addressed to some extent, though the solution is costly. The way to address this problem is to come up with different kinds of tests that assess vocabulary with different methods. So you could have another vocabulary test that doesn't involve pictures, but maybe words, or another test that involves nothing to look at, but just spoken definition, or different kind of responses like saying yes or no, or things like that. And so all of these different tests taken together, number of picture selections, correct judgments, and other kinds of things would be jointly affected by your latent construct, whereas the effects of the different task requirements would be different in each test because of the different designs and would normally cancel each other out, leaving the strongest effects from the common factor here, your target latent construct. This means that in order to measure somebody's vocabulary free from influence of task-related demand factors, you should be using plenty of different tests for the same thing, which is not always practically possible. But just because it's not practically possible doesn't mean that using one test tells you only something about vocabulary. So more generally, we have the issue of validity. Remember, we mentioned reliability before. Reliability was whether you can trust that you're measuring something. If you have no reliability, you have nothing. But if you're measuring something, then you want to ask, what is it that I'm measuring? If you're measuring what you want to measure, then you have a valid test. To assess that, people try things like correlations between measures that are supposed to assess the same theoretical construct. They should be highly correlated if they assess the same construct. And conversely, tests that assess different constructs should not be very highly correlated. Tests that assess a certain construct should also longitudinally predict future performance of other measures that are theoretically related. For example, a vocabulary test in preschool should predict reading comprehension in middle elementary school. And tests should also discriminate the relevant populations. So if you make a reading test, one way to check if your test is really a reading test is to see if people with dyslexia get much lower scores than people without dyslexia. So all these kinds of checks are meant to indicate if the test is approaching the target dimension to a satisfactory degree. Let us go back to our original diagram. So this is the latent construct we're interested in for any kind of assessment test. And this is the observable performance that we can actually see and gives us a score on the test. We use multiple items in order to have a better estimate of performance and in order to span the range of skill that our assessment instrument is meant to discriminate. This performance is not only dependent on the latent construct, unfortunately. It is necessarily dependent on other general and specific factors and situational factors, and it is also dependent on method variance, that is, task demands due to the design of the interaction. But this isn't all. There's one more thing. General and specific factors and method variance are systematic sources of error, and they're called bias, and they affect test performance to distort the outcome in a biased way. In addition, there is noise, or random error, which is non-systematic variance and can be due to things like temporary distraction or due to the probabilistic nature of this connection. So the same item may sometimes lead to a correct and other times to an incorrect response due to circumstantial random effects that are cumulatively called noise. So random error, as well as various sources of bias, are present in the only thing that you have, which is the test score. And this you should always have in mind when you use a test, and you should always dive into the test documentation where you can see the evidence for the extent of each of these effects for every test that is properly made and well studied. Well-made tests are not free from these problems. Every test is susceptible to these to some extent. Well-made tests are those that have attempted to minimize those problems and, most importantly, have documented precisely the extent of those problems so you know exactly how much you can trust the test score and how you should interpret it.